This video is all about finding trig derivatives. Make sure you like the video, send it to a friend, and subscribe below. Most people don't like finding trig derivatives. They're kind of ugly and difficult problems. But today I'm going to show you a way to find all the trig derivatives in case you were to forget them. The next video will include examples on how to solve trig derivative problems. All right, to find the derivative of sine of x, the first thing we're going to do is graph sine of x. And if you don't remember your trig functions, it's definitely something you're going to have to review. But this is the graph of sine of x from 0 to 2 pi. And the way that we find the derivative is to find slopes, right? We all know that derivative is the slope of a tangent line. So we're going to graph tiny slopes along this sine x graph and then graph its derivative, and you'll be excited, hopefully, about what you see, what the graph is. So we're going to go along here, and these are positive slopes, right? And then what happens at the top, of course? You have a 0 slope. Now let's go down the other side. As you go down, these are negative slopes. It gets a little steeper here in the center, and then it starts heading to smaller negative slopes until you hit another 0 again, and then coming back up, we have more positive slopes, and those slopes are getting steeper in the positive direction. So now we're going to go ahead and graph our derivative. The first thing I like to do in graphing a derivative is marking the zeros. So we have a 0 here, which means down here, I'm going to have a dot when my y value is 0. Same thing at this 0. You go up to where y is 0 and you make a dot. So we know that's where the function will have to cross the x-axis. Now I'm going to look at my positives and negatives. I'm going to go to the center part first. Right here's a big negative. So I'm just going to put a dot down here at a bigger negative, because then all of these, this is getting smaller negatives to a bigger negative, and then smaller negatives will come back up following this curve. If we look at this first portion up into the zeros, we've got some positive numbers up here, so I'm going to put a dot, and then they get smaller positives until they hit 0. And again, on this right-hand curve part, there's smaller positives until they hit a bigger positive up here. Now we're going to go ahead and just graph this derivative. So we start at the positive, we head down towards the 0, we're in the negatives, we hit that big negative, now we're getting smaller negatives, we hit the 0, and we come up through the positives. Look at that graph. Please tell me you have something in your mind with light bulbs going off going, I recognize that graph. I know what that is. And hopefully you're all saying, that's cosine of x, right? This is the cosine of x graph. So the derivative of y equals sine x is cosine x. So the derivative of sine x equals cosine x. Make sure you get that down. Now, we're going to go to cosine of x, and we're going to graph its derivative and see what the derivative of cosine x is. So again, I'm going to start with drawing tiny tangent lines to find the slopes to graph our derivative function. We're going to start up here, and these slopes, as you can see, these are negative, and these are pretty big negative slopes. And now they're getting a little less steep, because as you can see, we're going to hit a horizontal line, which means this is a 0 slope at the bottom. Now as we go back up this side, these are positive slopes. As we get up, it's a little steeper in here. But now these slopes are getting a little smaller positive, because what do we know about that cosine graph? What do we know about that cosine graph? That cosine graph is going to top out at the top, and then it's going to start another. So this is going to start heading, these are going to be small positives, because up over here somewhere you're going to have another 0 slope. So now let's go ahead and graph this function. We know over at pi we're going to hit 0. So that's the first thing I'm going to mark. We're going to hit 0 here. We know that our biggest negatives were in the center here, about pi over 2. So I'll put a dot at a big negative. And then over here is where our positive values got to be the highest. And here they're going to go back down again. So let's put this together here. Because we know that this guy is heading back down towards 0. Remember, this guy would be 0 up there at the top. Look at that. Please tell me this looks familiar to you, but kind of, right? It kind of looks backwards or maybe upside down, or if you take a mirror to it. Exactly. It is negative sine x. It's sine x, but flipped over on itself. So, the derivative of cosine x equals negative sine x. Make sure you get that down. So it's funny, quite interesting, how the derivatives are kind of related to each other. And remember, you can always find them by graphing the slopes, the tangent lines, and graphing its derivative. Now we're going to use these two derivatives that we found to find all the other trig values, because we can build all the other trig values off of sine and cosine. So what we're going to do is we're going to use the quotient rule to build the rest of these trig function derivatives. Y equals tangent of x. Hopefully you all remember your trig to know that tangent of x is sine x over cosine of x. And now you know we need to use our quotient derivative, which is low d high minus high d low all over low low. And if you don't remember that, you can check out my other video where I explain how to use all those derivative rules. So we're going to use low d high minus high d low all over low low. That is our quotient derivative rule. So now I need to label my high piece and my low piece to do this. My sine x is going to be my high piece. My low piece is going to be cosine of x. The derivative of my high piece is cosine x. So I'm going to put that in a thought bubble so I remember that his derivative is cosine x. And then the derivative of my low piece is negative sine x. So I'm putting those in my thought bubble so I can easily pull them when I go to stick them into my equation. So y prime equals low cosine of x, that's this piece, d high, the derivative of my high piece is cosine of x, minus my high piece, sine x, times the derivative of my low, negative sine x, all over low low, which is cosine x squared. Now we're going to simplify the numerator. Y prime equals cosine squared x minus times a minus gives you a positive sine squared x all over cosine squared x. Hopefully you're all doing a little happy dance because you remember your trig and that numerator has a special equation. Do you remember what it is? Sine squared x plus cosine squared x equals 1. Yes, it equals 1. So this numerator just becomes 1. Like how fantastic is that? And then your denominator is cosine squared x. Now nobody likes dealing with a fraction, right? So do you remember which trig function is 1 over cosine? I'm actually asking you to pull back your memory and remember all your trig. But 1 over cosine x is secant x. And since this is cosine squared, our answer will be secant squared x. Got it? Therefore, the derivative of tangent x equals secant squared x. Now we got to do the next one. Cotangent. So hopefully you remember that cotangent equals cosine x over sine x. Right? And we got to do low d high minus high d low all over again. So this is my high piece, right? And his derivative is negative sine x. Here's my low piece, and his derivative is cosine x. So y prime equals low sine x times the derivative of my high piece, negative sine x, minus high cosine x times derivative of my low cosine x all over low. So sine squared x. Again, we're going to simplify our numerator. Y prime equals negative sine squared x minus cosine squared x all over sine squared x. Now hopefully you're seeing the property that we pulled out in the numerator of the previous problem, but sometimes people have a hard time rearranging it to make sure that your negative signs are correct. So let me show you how we're going to do that. The property is sine squared x plus cosine squared x equals 1. Well, in this case, these are both negative. So what are we going to do? Well, I'm just going to use that. I'm going to do some algebra, and I'm going to move them to the other side. So now they're negatives. Now we're just going to do some algebra and move them to the other side. So watch. I'm going to subtract sine squared x to both sides. So now you would have cosine squared x equals 1 minus sine squared x. Well, now I'm going to move cosine squared x because this one's minus as well. So now subtract cosine squared x minus cosine squared x. I'm taking a lot of steps to write this out. You don't have to do all this if you already know it. So now we have 0 equals 1 minus sine squared x minus cosine squared x. But I only want the sine squared x and the cosine squared x. So now I'm going to subtract the 1 to the other side. So now you have negative 1 equals negative sine squared x minus cosine squared x. So hopefully you can see now that this minus sine squared x and this up here just equals negative 1. So now we have y prime equals negative 1 over sine squared x. And again, hopefully you're remembering your trig function. Which trig function is 1 over sine of x? Hopefully you remember it's cosecant. So now this answer is negative cosecant squared x, which means the derivative of cotangent x equals negative cosecant squared x. Now we have secant x. So we're going to just rewrite this as 1 over cosine x. Low d high minus high d low all over low. You ready? Y prime, low cosine of x. D high, derivative of 1, 0. Minus the high piece times the derivative of low. Derivative cosine, negative sine x. All over cosine squared x. Let's simplify that numerator. That piece drops. We have positive sine x all over cosine squared x. I'm going to rewrite that part, show you how we're going to break that apart. Y prime equals sine x times cosine squared x. I'm going to separate this denominator, make this two fractions. So I'm going to have sine x over cosine x times 1 over cosine x. See what we did there? You have two cosines on the bottom to be cosine squared over here. Okay? I'm just separating them. Why? Hopefully you have light bulbs going off in your head, right? What's sine x over cosine x? Yep. We've got this guy is going to go to tangent, right? And this guy becomes secant x. So the derivative of secant x is tan x times secant x. We've got one more. Are you ready? Cosecant x, hopefully you all remember, is written as 1 over sine x. So the derivative, low, derivative of sine x is cosine x. D high, derivative of 1 is 0. Minus high, derivative of low, cosine x, all over low. Now we're just going to simplify the numerator, right? This piece drops. We're left with minus cosine x. Don't drop that minus sign. All over sine squared x. Very good, right? And now we're going to do the same thing we did in the previous problem and pull apart that fraction. So now we have negative cosine x over sine x, because remember I'm separating the denominator, 1 over sine x, right? And hopefully, again, you're getting excited about your trig because you see that this piece right here becomes negative, just don't drop that negative sign, cotangent x, and 1 over sine x becomes cosecant x. So the derivative of cosecant x equals negative cotangent x times cosecant x. I know, it's a mouthful, but these are the things you need to know. And if you ever forget them on a test, you can always solve for them to find them to make sure that you're doing it correctly. These are all your trig functions and the derivatives. Make sure you get these down in your notes. Stay tuned for the next video where I will have examples on how to solve trig derivative problems. Make sure you like the video, subscribe, and share it with a friend. I know, it's a mouthful. That's a whole heck of a lot of algebra.